major three projects, that is Model 1, Model 2, Model 3. First one, normal Cessna aircraft. Second one, that is our commercial plane. And third one, helicopter. And this is our final model, that is fighter aircraft. Okay, so we'll be going to design fighter aircraft by using our OpenVSP software with the help of some geometrical parameter. Okay, so I'll be taking this aircraft as example. Okay, we know this Desert Rifle, it is also one of our fighter aircraft. Okay, so generally this aircraft we'll use for our fighting purpose, right? So that's why we call this aircraft fighter aircraft. Okay, so this is just as we all know, recently our India also, they have purchased Desert Rifles, and it is originated from of country, that is France, right? So that is just a basic introduction about the Desert or the fighter aircraft. Okay, so here we have our views. By using OpenVSP, you can place your view. Okay, but we have top view, side view, and front view. These views we can use in our OpenVSP as a background, and we can adjust the background, and we can develop our model. That is one option. And the second option is to go according to the parameter. Okay, so we can go according to the parameter. As we know, this is our military based aircraft. Okay, so that's why most design parameters we will not find easily. So here I have just considered rough design parameters. Okay, and from one source and also from VSP source, we have some parameters. We will use those parameters and we will generate our model. Okay, that is Desert Rifle fighter aircraft. So let's go to OpenVSP software, run this one. So here this aircraft, let me select a pencil. Yeah, so totally we have number of parts. Okay, that is fuselage, wing, canard wing, and our vertical stabilizer. So we'll differentiate our parts. I will call this one as fuselage, main wing, canard, and vertical stabilizer, VT. VS, okay, sorry, VS, vertical stabilizer. In this fuselage, we can observe fuselage is not like with constant diameter or with constant shape, right? So there is a change in the cross section from the nose to the tail, right? From starting point to ending point. Okay, overall here we can observe fuselage length is okay, what we have some length L. Okay, in that length L, the cross section is not same. Okay, there is variation in the cross section, and fuselage shape also we have to change, which means we have to divide our fuselage into 3 parts. Then only we can design, or we can achieve this kind of shape by using OpenVSP software. So what we can do, we will differentiate complete fuselage into three parts. That is, we will call this fuselage top one as a top fuselage, and this part, that is main fuselage. Let me copy this one. Yeah. Okay. So what I told here, we will call this portion. Okay, this portion main fuselage. Okay, and this side what we have, we will call this one as a side fuselage. Okay, these two what we have, we will call this portion or this part side fuselage, and here we have bottom fuselage. Okay, so like this we will differentiate, and we will design each and every part separately in the OpenVSP, and then we will assemble. And here no need to split our wing section, because this wing is like completely delta wing, like this. Okay, so no need to split, we'll go according to that. Okay, like this we can design delta wing. Yeah, and after that we have our canard wing. So with the help of wing section we can complete this part, right? So now we'll go to main wing. So go to OpenVSP, select wing and add. Here we have default wing. I'll just take wing portion. Okay. Okay. So here the shape, it is like this. Okay. Okay. So here we have our default wing. For this default wing, we have to change the parameter as per our requirement. Okay. So here I'll just mention the wing parameters. Okay. Overall span. Just 2 minutes. Let me charge. Okay. Yeah. So span for this case is 11.2 meter. Okay, and we also have chord length 5.01 meter, and our area. So we'll use first these two parameter. From here to here, that is our B span 11.2 meter, and chord this length 5.01 meter. So we'll go to OpenVSP, and here we'll come to plan form. We'll change the span, that is 11.2 meter, and our chord 5.01, enter. Okay, yes, so here what will get the area and aspect ratio, let it be, because two parameter, based on the two parameter, of course you'll get rest two parameters. So okay, because we know aspect ratio AR is equals to B square by S. Okay, so let it be, no need to do any changes. Now we will jump to the next menu, that is section. Okay, here we have to alter all these values. I mean, like, we have to change our values, these default values. So we know our span, it will get update, root chord, and we have tip chord. So tip chord, I'll just mention tip chord. Just take tip chord 1.6859, enter. Okay, this one. This is our tip chord. CT, that is 1.6852 meter. Okay, now what we have to do, we have to go to sweep angle. We have 30-degree sweep angle. Okay, but according to our requirement, the sweep angle is, okay, which means this angle, it is 50-degree. Okay, so we will use sweep angle 50-degree, enter. Then now after this we will come to aerofoil. Yes, so we have default aerofoil. We'll change this to small, thick, thin aerofoil. Okay, so instead of 10% thickness to chord ratio, we'll change this to 3%. Okay, because we don't need a thick aerofoil, especially for fighter aircrafts. You can observe here we have our aircraft. Okay, if we take the cross section of this wing, then we can able to see the wing cross section or the aerofoil, that is the thin aerofoil. Okay, aerofoil will be completely thin, not thick. So that's why we will go with thin aerofoil, which means we will reduce thickness to chord ratio to 3%, or okay, 3%. We'll just type 0.0335, enter. Yeah. So camber location, okay, let it be. Because no need to keep any camber, let it be. Okay, now we will jump to roadside. So here also what we'll do, we'll roadside, here you can observe. Okay, so just we'll just increase the thickness to chord ratio near the roadside. Instead of 10%, we'll go with the 13%. Okay. Yes, yeah, here we have top view, front view, and left view. Okay, yes, this is our tip side aerofoil, this one, the cross section, and this is our root side. Okay, yes, So now we can save this one, which means we have done with our main wing. Go to file and save. So before that, you can shade, you can even have a preview of this model. Top view. So it's not completely straight. So we'll come to section and 0.5% angle will reduce, which means we'll go with 40. Okay, let me type that value. We'll go with 0.5%. Okay, 0.5, which means we'll go with 49.5 degree. Okay, like this you can adjust. You can round up to 49, or else you can round up to 50, your wish. If you want to show like this, you can use that angle, sweep angle. Otherwise, you just round off to 49. Let it be now 49 itself. Yeah. So we'll just go to file, we'll save. So this is our fighter jet part 1 main wing. Okay. Accept. We have done with our part 1. Now next we'll go to this part. Canard. Canard wing. This one. Okay. Here we have that wing. Yes, this wing is forward to the main wing. Okay, which means this wing what we have, it is placed forward to main wing. So such kind of arrangement, if we find, then we can say that is our canard. Yes. So we will go to file and we will go to new, because now we are dealing with new geometry. So geometry is like a wing geometry itself. Okay. So that's why go to open VSP and wing. Now here we have to use the parameters. As I told, easily will not get all the parameters, especially for fighter aircrafts. Okay, so I'll just give some rough values which already done. Okay, so this section I'll just take separately here. I'll just take symmetry part. Okay, so overall span. Okay, let it be full. That is 4 point. B is equals to 4.83 meter, and our chord length is this one. It's 1.7 meter. Okay, 7. We'll use these values. Come to plan span, that is 4.83, enter. 83810, enter. And our chord length is 1.74, enter. Okay, so after this, what we have to do? We have to go to the next menu, that is section. So no need to split the section, because here we don't want any such complicated kind of wings or second sweep angle like that. Only one sweep angle is enough. Okay, so that's why no need to split this wing. So here we have sweep angle. So the sweep angle is 49 degree. Okay, so for this case we have used 50, and we have rounded off to 49, right? So for this also we will use 49. Okay, 49 or 50. So I'll just come to sweep angle. Default we have 30 degree, so I'll just use 49, enter. So now tip chord that is 0.52. 0.52 meter. Okay, yeah, yes. So after this, what we have to do? We have to shade this one, and let's check the views. Okay, okay, come to aerofoil. Default we have 10% thickness to chord ratio. Okay, let it be. It's thin aerofoil itself. Okay, so we'll jump to tip side. Okay, okay, let it be. It's 10%. Okay, which is like a thin aerofoil itself. So now we'll just go to file and we'll save this one. So this is our fighter jet part 2, that is Canard. Okay, now we have done with the main wing and canard wing. Okay, so now we will go to fuselage part. So just go to file, go to option, new option, select fuselage and add. Yes, so here, as I told in the beginning itself, we will divide our complete fuselage into three parts. Okay, one is our main fuselage, the black color mark what I am given here. That is our main fuselage, side fuselage, and this one we will call top fuselage. Okay, so first we will go to design. Okay, we'll just go with this main fuselage. Okay, yeah. So here, mm, overall length of this main fuselage Yes, just wait. Yeah. So from here to here, overall length of that main fuselage, which is marked with the black color. I'll just mention here. It is 14.763 meter. Okay. So we will come to design. Here we have length. So we will give our fuselage length, that is 14.763. Enter. Okay. So after this, what we have to do? We have to go to cross sections. Okay. So currently here we have totally default number of cross sections, that is 4 number of cross sections. So here fuselage shape you can observe. Okay, we have to vary from here to here, from here to here, again from here to here, from here to here, and again from here to here. Okay, which means more than 4 cross section is needed. Okay, then we will just come to second cross section. Okay, or third cross section. Okay, in between second or third you can insert new cross sections. Okay, so I'll just insert new cross section. Okay, just beside this third cross section. Okay, so I'll just insert 2 times 1 and 2, which means 2 cross sections has been added extra. So here totally 4 plus 2, that is 6 number of cross sections. Now currently we have 6 number of cross sections: 1, 2, 3, 4, 5 and 6. Yes, so now we will come to each and every cross section. Okay, and we will generate main fuselage. This one, this part. Okay, so I'll just mention parameter directly. I will not show here. Okay, just use that parameter because it's little confidential kind of thing. Okay, yeah. So we will close our geometry. Okay, here this side, nose side, we have to close. So that's why we have to select the cross section type, pointed type of cross section. Here you can observe it's like a pointed type of cross section. So that's why 0th cross section you have to select the cross section type, that is pointed type. Now jump to first cross section. First cross section. Okay, so here just we will give our cross section translation value. Okay, that is where it is located. So from this nose point, the cross section is located at a distance of 1.767 meter away. 1.767 meter away. And the cross section type, we have to select fuselage type of cross section. Where we have, yes, here we have our general fuselage type of cross section. Okay, now I saw here, yeah. So here we have to change the parameters of this general fuselage cross section. Okay, so I'll just mention the height. All of you just follow with same parameter: 0.81 to 52. Enter. That is our height. And width 0.80962. Enter. Okay, and rest of the things let it be. No need to do any changes. Upper structure, okay, a little bit. We'll just increase this to 93. Okay. Top structure, we'll just reduce this one. Okay, so now we'll go to next cross section. So now we are in the second cross section. So second cross section, it is located at a distance of 5.30 for to enter. Okay, and here we have to change the cross section type, that is general fuselage. Height of this general fuselage type cross section, it is 1.428 meter, enter, and width 2.66. Okay, 2.66, enter. Yeah. So here maximum width location we have 0. So what we'll do, we'll just change the maximum width location. Okay. Okay. And corner radius, this radius will increase to 0.5. And 0.6. Okay, let it be. Now we will play with the top structure just to get some shape, fuselage kind of shape. So I'll just increase this top structure to 1.14, enter. Bottom structure, I'll just reduce this one. Yeah, because here you can observe the view. Okay, this kind of shape we need, no? Front view of the fuselage is given. So we don't know exact dimension, but just we want to create that kind of aircraft, or we have to design that kind of aircraft by using open VSP software. So you can play with the parameters what you have till you get you that kind of shape. Okay, so 0.36, enter. Okay, now lower structure, I'll just increase this one to 2. Yes. Okay, you can observe quite same structure we have. Okay, yeah. So I'll just jump to next cross section. Okay, yeah. So here this cross section, what we have, third cross section, it is located at a distance of 8.22 from this nose point. Okay, 8.22, enter. And same, we have to select the same cross section type, that is general fuselage. And here height is 1.31, enter. And width is 2.7. So now we will play with the maximum width location and all other parameter. Okay. So I'll just round up to 1.3, 0.13. Okay. And same what I have used previously, that is 0.6. Top tangent angle. Okay, we don't need 90. Okay, we'll use 11. Bottom tangent angle, we don't need exactly 90, because if it is 90, then you can able to see the flat. We don't need flat. Okay, so we'll just use this one, 0. Yeah. Now top structure, it is very less, this one. So I'll just use 2. Okay. And bottom structure, we don't need this much. Okay, So I'll just reduce this to 0.5. Yeah, and upper structure, we have to increase this one. So I'll just round off to 2. Okay, and lower structure also, I'll just increase to 2 feet. Okay, yeah. We are moving back. Okay, so that's why the shape is also changing. Now, jump to next cross section, fourth cross section. And this fourth cross section, okay, it is located at a distance of 11.07 from this nose point. Okay, from here to here, the distance is 11.07, or you can round off to 11 meter. Okay, and cross section type is general fuselage type of cross section. And here we have to use the parameters. Okay, height is 1.19 meter. We are moving back, which means the shape of our geometry or shape of our model, it is decreasing. You can observe. Okay, so we have to get this shape like this. Yeah, so now maximum width location, we will use the same what I have used previously, that is 0.13 meter. And corner radius, we will just use same 0.6. Top structure 90. Okay, 90 is not suitable. Okay, because we don't need a complete flat top side tangent angle, so we just reduce this to 43. And bottom tangent angle, we don't need this 90 degree, so just type 0. Top structure, this one, okay, it is less, so just use 1.1. And bottom structure, okay, we have to reduce this one to 0.5. Upper structure is too much, so what we'll do, we'll just reduce this to 3.6. Lower structure, okay, little bit, okay, we'll round off to 2. So now we'll jump to next cross section. This is our fourth cross section, and sorry, fifth cross section. This cross section, it is located at a distance of 14.76 meter, and here the cross section type is same, general fuselage type of cross section. Okay, which is having a height of 1.03 meter, enter, and width of 2.11 meters, enter. Same what I have done previously for fourth cross section, maximum width location and corner radius, same we will use here, that is 0.13. And corner radius 0.6, enter. Okay. Top structure, now we have to increase little bit. Okay, previously we have used 45 something, right? So we have used 43, so here we will increase this to 74. Okay, 75 or 74. Now we will make this bottom tangent angle 0. Okay, top structure same, and bottom structure same what we have used previously. Okay, this one also will use same 3 6. Lower structure same. Yeah, for fourth and fifth cross section approximate same parameter we have used. Only the thing is that height and width we have changed. Okay, not much in a point, that's it. So now we will jump to sixth cross section. We know that this is our last cross section and the cross section should be closed, so that's why the cross section type is pointed type of cross section. Okay, so here let me check the views. This is our top view, front view, okay, okay, yeah. So I'll just use wireframe option, and here we have our left view. So we will use this one. Paste here. Okay. So now what we'll do, along Y direction, we'll translate along, not along Y, sorry, along Z. Okay, along Z we will translate so that we'll get the shape like this. Okay, especially the main fuselage, not top one, not even the side one, because as I told, this is our main fuselage. Okay, this one. Okay, so later we'll go to top and sided. Okay, so here we will translate along Z. First come to each and every cross section. Yeah, zero cross section, no need to do any disturbance. First cross section. Here we have first cross section. Little bit we have to disturb. Okay, so I'll just okay, let it be zero itself, no need to do any changes. We'll go to second cross section. Here we will change. Okay, we'll just use 0.1 meter. And third cross section 0.07 meter. Fourth cross section will maintain same 0.07. Cross section 0.35. Okay, and sixth cross section will maintain same 0.3. Little bit will reduce. Okay, previously it was 0.35, so we will just take this one 0.32. Yeah. Okay. Okay, this portion is done. This one, black I have marked here with black color. Okay, that portion is done. So that is our main fuselage. Okay, so now we will go to top fuselage. So share this one and save. Fighter jet, part 3, main fuselage. Okay, yeah. Mm, so main fuselage is done. We will go to new and we will add default fuselage. Okay, yes. So now here the overall length of this top fuselage is from here to here, that is 13.33 meter from here to here. It is 13 point meter. So we'll come to open VSP and we'll come to design. Overall length is 13.33. Okay, so after this, we have to come to cross section. So here we have to use extra cross sections. Okay, default we have 4, so I'll just add 3 more cross sections, 1, 2, 3, and I'll come to each and every cross sections and quickly I'll just give values. Okay, because already time up. I'll just yeah, zeroth cross section we know geometry should be closed, so that's why I'll just use pointed type of. And first cross section, what we have, okay, this first cross section we should not translate, so let it be 0. Okay. And what we will do, we will just change the cross section type, that is general fuselage, and here I'll just mention the height 0.81 meter and width 0.432 enter. Okay. So after this, rest other parameters we have, let it be, no need to do any changes. Just jump to second cross section. Okay, here this second cross section, it is located at a distance of 1.99 meter. Okay, and the cross section type is same, general fuselage type of cross section, and height is 0.89 meter and width is 0.84 meter. Enter. Okay, and rest other things what we have, let it be, no need to do any changes, but here we'll just have a preview. Okay, so here okay, we need so what we'll do, we'll just alter the top structure, or not top structure, let it be yeah, we'll just change this to 0.77 for structure, 0.5 5. Okay. Bottom structure also will just reduce a little bit. Okay. We'll jump to next cross section. So here we are in the third cross section. What we have to do, we have to just place our cross section. Okay, this third cross section, it is located at a distance of 6.11 meter away, and cross section type is same general fuselage type of cross section, which is having a height of 0.71 meter. 0.71 meter. Enter. Okay, and width is 0.95 meter. Enter. And here, okay, let it be. Yeah, okay. Okay, here, top side, you can observe top side, this one. Let me copy this one. Yeah. Okay, here, this is our top fuselage. Okay. So just jump to fourth cross section. Fourth cross section, it is located at a distance of 10.0. I mean 10 meter away. And the cross section type is same general fuselage type of cross section, which is having a width of 0.71 meter and sorry, height 0.71 and width 0.95 meter. Okay. Yeah, no need to do anything. Just jump to fifth cross section. Okay, this fifth cross section is located at a distance of 11.46 meter away from nose point, and the cross section type is same general fuselage, and height is same what I used for previous section, that is 0.71 meter, and width is 0.95 meter. Enter. Other things, let it be. No need to do any changes. Come to seventh cross section. Okay, so here, okay, sixth is done now. Yeah, so we have done with six. Fifth also we have done. Okay, so here fifth one I have not changed. Sorry, fourth is done. Okay, sorry, I just skipped the fifth one. So this fifth cross section, it is located at a distance of 11.46 meter away, and the cross section type is general fuselage type of cross section, which is having a width height of same, say 0.71 meter and width of 0.95. Okay, enter. Rest other things, let it be. For sixth also same. Okay, only we have to change this one, that is 13.33 meter. Height, it is not 0.7, it is 0.38, and width is 0.28. Okay, rest of the things, let it be. Now just jump to 7 cross section. We know this is our last cross section, so that should be closed. Okay, so we have done with the top fuselage. Only the thing is that now we have to translate alongside to get that zigzag shape. Here we have our top view. Okay, and this is our front view and left view. Okay, let it be this left view. Now we'll come to each and every cross section. We will translate this along Z. Okay, so it should move a little bit down. So that is minus 0.52. And first cross section, same, minus 0.5. That will be minus 0.5. Minus in the sense I am pulling that downside. Okay, plus in the sense taking it upside. So minus in the sense going down. That section is going down, which is nothing but I am bending that part by using the axis. Which axis? Z axis. Okay, so just jump to second cross section. Second cross section, Z value 0.45, and third cross section 0.14 meter. Fourth cross section, same. You have to give constant value, that is 0.14 meter. Okay, so fifth cross section, same, this one, yeah, 0.14 meter, enter. And sixth cross section, here we will just increase a little bit, 0.15. Seventh cross section, 0.15. So this is our top portion. Front view. Okay, so which is like this. Once we assemble, then you will understand. Okay, this is what we have done. So now just go to file and save, and rest other parts we will continue tomorrow. Okay, so just go to file, save this one. This is our fighter jet part, that is part 4, top fuselage. Accept. Okay. Okay, then we'll just complete rest of the parts in the next session. Yes, sir. Shall we stop the session?
Okay, sir. Thank you.